Live. All right, welcome back. We are Game 2014 in the fall 2020 semester at George Brown, and it's Mobile Game Development 1, and it's week 7. All right, so before we start, I just wanted to put this video up on our content area. So in week 7's content area, this week we're doing a midterm test, and I just went through the details in a Zoom recording, which I'll be posting up on Blackboard Direct. So don't expect to see something live on YouTube. It's not going to happen. I'm going to put it here on Blackboard for you guys. But for this recording is really about, let's see if I can get this going here. This one's really about the lecture component, which I want to share with you guys on YouTube, so you can look at it later for your theoretical test that's coming up next half of semester. There you go, there's that video. Okay, so let's get back to this. All right, so like I said, today we're supposed to be doing touch, input, presses, and gestures, but I'm going to move this off into week 9's content, only because I think that people are going to be consumed with doing their midterm test, plus there's other midterm stuff happening, and giving you additional information today that's super important, like touch, input, presses, and gestures, is probably a negative. So for today, the actual stuff I'm going to be doing is up on GitHub. So if you take a look at github.com/George Brown, you'll see that there is a lesson 7 starter. Please download this if you want to follow along. Okay. And there's no lab 5 today because, again, I know that you guys have many midterms, you guys have other things going on, and so this would be something that would be an additional to what we're doing this week. So that's why it's lesson 7. Okay. But there is a repository that we'll be using in the future. For future lessons, I'll be building on the stuff that we've been doing slightly, and then we're moving in the second half of semester to more of a platformer type game as opposed to a kind of a top-down space shooter type. Okay, but we'll be finishing off in 1 week. We'll kind of finish off the space shooter and start, the new project, which is going to be more of a platformer type. So what are we doing today if we're not doing this? Well, we're actually doing. I got a couple of reminders. One, assignment 1 part 2 is due Sunday, and the midterm test, which I released today, is due on Saturday. So Saturday night at midnight. Now this should not take you until Saturday to do. I've timed the test, so it should take you approximately, I would say, 2 hours max. If if you didn't know what to do, or if you were, if you struggled with Unity. But for the most part, most of you should be able to finish it off within about an hour max, with the video wrapped in and everything. 1 hour and you're in and out, you're done, and which is about right for a midterm. If we're sitting together in the real world, I wouldn't give you a midterm that you'd submit the entire week. It would be like, here's your midterm, get her done. You'd have access to nothing, kind of thing. Here you have access to everything, but I'm not going to make it super difficult because I know you have other stuff that's super difficult. Okay, so today we're going to be talking about the Singleton design pattern, what it is, and then how to use it to transform the factory and the bullet pool, the bullet manager, into a singleton. How do I do that in Unity? What are the nuances? There are some nuances in Unity. Let's talk about what the singleton pattern is. And we've seen the singleton before. This is not the first time. All of you, I think, that are here have seen a singleton design pattern, right? So just to make sure, has anyone not seen or heard of the singleton design pattern? The people that are here in class with me today. If you haven't heard of it, X. If you've heard of it, we're good to go. Don't do anything. All right, so everyone's heard of it and they've used it because we use the singletons a lot in our SDL engine that we kind of work with. Alex has used them and so do I. So it's not like you're new to them. However, let's talk about it just again as if you never saw them before. So what are they? They're a creational pattern that allows you to create a single instance, right, while providing a global access point to this instance. So here is the kind of funny things about singletons. They actually violate the single responsibility principle. And what are these principles we speak of? Well, remember that a lot of the design patterns are based on something called solid principles, solid design principles. So single responsibility is the first one. Then there's open close. Then there's Liskov substitution principle, and so on. So it's solid. There's an acronym. And single responsibility is one that Singleton violates because it tries to do two things at once. Be a single point of access for, as an example, for your class, as well as you want to create a single instance. So there's two things that are happening there, and this is where people get messed up. It's really like we're creating a managed global variable or a managed global object that we're using. Okay. Okay, so what does it do? So the first problem is we want to ensure that the class is a single instance, right? And why would anyone want to control many instances a class has, right? The most common reason for this is to control access to some shared resource. For example, a database or a file or a manager in our case, or a factory, something like that, okay? So there's good reasons for it. Here's how it works. Imagine that you created an object, but after a while decided to create a new one. So you have made another factory and another factory somehow. You have multiple factories going on and multiple managers. You're creating a new sound manager, but there's already one that's in play. You can make mistakes, and you can actually have, kind of more than one instance of the same object that you're trying to access, and it can cause issues. Okay. Now, not so much in Unity, but definitely in C# and C++. Problem 2, you want a global access point, a single place where you want to be able to access an object. Okay, so this is why it violates the single responsibility principles, because it's solving two problems. So here are the two problems again for your study, for your theoretical tests: a single instance and global access point. Those two things are very different, right? Remember that those global variables we used to use, before, they were unsafe because we could overwrite them by accident. Well, now we're going to make it so that it's, kind of a safe spot to access this object, as an example, and so we can use a single instance of the same kind of class, system, manager, whatever it's going to be that's inside of our code. So one thing that Singleton does that's a little different than just making a static global object is it protects the instance so that it can't be overwritten by other code, and there's only one single instance out there, right? If we're going to have code that solves the first problem, which is an instance, then we don't want it scattered all over the place. We want it within one class. And nowadays we see the Singleton everywhere. It's so popular that it's maybe overused, and we'll talk about that later on. So what's the solution? Well, you make the default constructor private so that you can't instantiate an object of that another object of that class, right? And we don't allow you to use the new operator, and that would be in C# as an example, or make an instance of that class through the constructor function. We won't allow that. The second part is we want to create a static creation method, and usually we call that creation method instance or getInstance, that acts like the constructor. So similar to what we abstracted away the ability for us to create new instance objects through the factory method, right, where we access the factory method pattern and it would just spit out products. But we don't use the new keyword there, or we don't use instantiate in Unity. We let the factory create the products for us, right? And then we use them. So similar to do that, we don't use the new keyword, or we don't use, the constructor. We just kind of access the class through its creation method, usually called instance or getInstance. If we have access to the Singleton class, then it's able to call the Singleton static method. So whenever the method is called, the same object is always returned. That's the solution. So the real world analogy would be more like the government. Government is a good example of that. A country can have only one official government, regardless of the personal identities of the individuals who form governments. The title, the government of, fill in the blank, is a global point of access that identifies the group of people in charge, right? There could be only one. All right, and let's take a look at the structure here that it would look like. So when we're looking at the UML diagram, really what we're looking at, remember UML, the first box here in this container, it indicates the name of the class. In this case, it's called Singleton, right? Then this next box it usually is the attributes box. The attributes box is our properties. We have a property that's called instance, so a private instance member that's called singleton, and it's underlined. Underline means static. That's what it means in UML speak, if you will. So a private static attribute called instance that returns a reference to the singleton class itself. And then our constructor function is also going to be private constructor, right? On the methods or operations side, we have a public static, the underline is static, method called getInstance, which also returns a reference to the singleton class itself, whatever that singleton class is. So that's really the way it works. And they've given you some examples here. Right here it says if instance is equal to null, then make a new instance, otherwise return the old one. That's kind of what's happening inside of this little thing right here. And it explains it here. It says singleton class declares a static method getInstance that returns the same instance of its own class, right? Okay, well, applicability. When are we going to use this thing? Use the singleton pattern when a class in your program should have a single instance. And a good example of this would be some kind of database object, or a manager class, or some kind of system. For example, let's say I made a quest system. There should only be one of those. I shouldn't have to instantiate a quest system. It should just be one quest system that I'm always accessing. An achievement system. I'm only going to be accessing one achievement system. A scoreboard. There should be only one scoreboard, right? These are all good examples of classes or structures that I only need one of. I don't need multiple ones. I'm not going to instantiate new scoreboards every time or new achievements. The achievement should last for the entire game, right? Use the singleton pattern when you need a stricter control over global variables. So let's say, for example, I also want, not just in terms of a class, but let's say, for example, I have some configuration variables that I want to have, kind of accessible. For example, screen width and screen height. I always want those variables around, or I want other variables, other configuration variables that I want to have available to me. You create a singleton class, and that singleton class houses those variables, and there's strict control on how to get access to those things, as opposed to make them use a static class. That's wrong. If you use a static class and add a bunch of variables, that would be a negative pattern, an anti-pattern actually. Okay. So how to implement it, we talked about this. Make a private static field, that's number 1. 2, declare a public static creation method. 3, implement lazy initialization in the static method by making a new instance of that object. Make the constructor class private. I honestly think that I would probably do this number 2. I'll probably say make a private instance, make the constructor private, so that I have to use some kind of creational method to do number 2 and 3. And then finally, number 5, go over the client code. We're going to see a lot of that today, and replace all direct calls to the singleton's constructor with calls to the static creation method, whatever that is. How does it look in C++? Classic implementation looks like this, and we've seen a classic implementation like this before. The class, let's say, is called singleton. Notice here at the bottom, there's number 1. So 1, make a private static instance method, instance called s_p instance, which returns a pointer to the singleton class, whatever that is. 2, make your constructor and all other silently generated functions private, so that they cannot be accessed from outside of this class. 3, create a creational method called instance or getInstance that returns a pointer to the singleton class, right? And then 4, make use of lazy initialization, which is s_p instance is equal to new singleton only when, if and only when, that the instance method has been accessed. Because let's say, for example, a user wants to get access to some function, they go through the instance method to get to some function. Think about the instance method as a gateway or some kind of threshold before I get to some function. So I have to go through my instance in order for me to get access to whatever the singleton class has inside of it. That's how it works. So control again. Now, one thing to notice is that this is not a thread-safe implementation. So if you were in a multi-threaded environment Because of the way the singleton works here and returns these raw pointers, this would be negatory. You wouldn't want to use this in a multi-threaded environment, not this way. So to the rescue, magic statics, right, which is also known as Myers singleton. Magic statics, more also formerly known as function local static initialization, is when a static variable is declared within a function and then passed to the caller. So that means that here's my function, the instance, and I'm returning a static instance to the caller of this function. And the differences between this singleton class and the previous one is, notice that the previous one uses it returns a pointer, whereas this one returns a reference to the static private static variable that we've created inside of our function here. And again, this is a magic static because of that, and it's supported in, I believe, C++ 11 and on, right? So we should be using this one. So one advantage is it still uses lazy initialization, so it still does this part, static singleton instance, still does that. But it's also thread safe, right? So that's the really good thing about it. So it's better than the other older version. This version is great, not thread safe. This one is better, and it is thread safe, and you don't need to have a private static instance outside of the creational method, which is good. So this is a better way of doing it, and going forward, Alex and I have talked about converting our little SDL engine to use this, okay, because it makes more sense. All right, what about if I have lots of singletons? Then maybe what I want to do is think about templatizing them. So I want to make a template class as an example, and this way, if I'm going to make use of singletons all the time, I might as well have a pattern so I don't have to do this same stuff every single time I do a singleton. It's a lot of work, right? I have to declare the singleton, make a static creational method, hide the the constructor and all those kind of things. Lots of work to be done, and it's the same thing that I do every single time. So instead of doing that every single time, instead make a template class called singleton as an example. Here we're going to pass static t representing the type. We're still getting a reference out of the type. And this looks like a magic static, which is great because it's thread safe, like we talked about. Instead of making things private here, we're making them protected so that the derived class that's going to derive, this is going to be an inherited class, right? Something that this is going to be a parent class or a base class for other classes that are going to inherit from the singleton pattern, right? And there's another really good reason to do this. One, it identifies as the class. If I try to do a type ID in C++ or a type of in C#, it identifies this class as a type of singleton. So I can identify if it's a singleton or not. Whereas in other cases, I don't know if it's a singleton or not. I can't tell off the top of my head when I look at a class, it's a singleton if I'm using it from another class, if I'm composing an instance. So this is a better way of doing it. So again, what we do is we set this constructor and the destructor in the protected area. The destructor, for it to be inherited, it's got to be virtual, okay? And then the rest of the silently generated functions, this is just some of them, would be deleted so that you have no access to those at all. So you can't do like the move constructor or the copy constructor or the assignment operator overload or anything like that. You wouldn't be able to do any of those things. It'd be all deleted. Okay. How do you implement this? So this is the base class, and the derived class would look like this. You would have we'll call this a manager class, some manager. So the manager singleton would be final. You wouldn't want to inherit from this at this point. It'd be like a leaf class, if you will. And then what you want to do is you want to use the singleton as the base class to inherit from. So it will extend the singleton, and you're going to pass in as a type, because you need a type, the actual manager singleton itself. And this funny syntax is the stuff that creates a singleton here, right? So you can see there's a lot less code that I have to put in. One thing I need to put in, though, is this friend class. If I don't put friend class singleton manager singleton, the problem that I'm going to have is it's going to complain down here in my private section, right? So what I still want to do is make my constructor and destructor private. My destructor is going to be override. It's going to override the destructor from my Singleton class, right? But both of them are going to be in the private area, which is still part of the structure. But again, a lot less code. I'm identifying this as a singleton. That's what this advantage is, as an example. And the pattern is going to be. We're going to maintain the pattern on the back end in terms of access. I don't have to even expose my instance method because we're going to do the same things over and over again. So I'm going to save some lines of code. Again, how much of a savings? I'm not sure there's going to be a great deal, but I think this is a great little pattern for us to use. How do you actually use this thing? Well, you would say manager singleton dot or delimiter instance, and then some function. So you see that the instance method doesn't exist inside the child class. It exists in the base class up here that we're accessing through the call to that function. So kind of good, and it'll say some function activated. Here's the test. All right. So again, we've talked about 3 different types of singletons. The first type is the classic singleton, magic statics, and templatized version. And I prefer the templatized version. I think going forward with the code we're going to do with the STL engine, we're probably going to do this a lot. Advantages for the singleton. You can be sure that the class is only a single instance, gain global access. This is kind of a review, right? Disadvantages, and there's more. Violates the single responsibility principle. Pattern solves 2 problems at the same time, which is not something we want to do. The singleton pattern can mask bad design, right? If I put a bunch of global variables in my code, what is that really saying? It means, there's other ways to do it with object-oriented design, or even protocol-oriented design, or data-oriented design, as opposed to use globals everywhere. I have to tell you that a lot of game programmers use globals. They just do it. It's just easier to get things done, and we can get the game going, right? But we should always look at the singleton and see, do we really need it? Because it can cause problems later on. The one big problem is testing. If I really want to make sure I test every single function using unit tests or behavior-oriented testing, right? Behavior-driven design, it's way more difficult to test a class that has singletons in it, or a project that has singletons, as opposed to one that doesn't, okay? Because how am I going to test each of those methods? They're always going to come back with the same. I'm going to go through the same gateway each time. It can be very challenging. I have to create something called a mock singleton sometimes, which can be a real issue. And sometimes, depending on how you implement the singleton, it may not be thread safe. And if it's not thread safe, especially now since we're using many times we're in a multi-threaded environment, it's not a good choice. Okay, so those are disadvantages. So what do we want to do now? So now we're going to do a little Unity example. Okay, so what I've done is up on Blackboard, let's go back to Blackboard here, right? There is a link for week 7, which is the GitHub repo for week 7. Please download this link. This is the one that I'm going to be working with this week. I'm also going to use this as a starter for Lab 5, which is going to be something we're going to do when we get back from break, not next week, but the week after. So this is what I'm going to be using. And I'll talk about what's in there. So for now, what I'm going to be doing is I'm going to make a copy of this structure here. It's going to take a moment, so bear with me. What I recommend while you're waiting, and for people watching, is if you haven't had a chance to start working on your exam, start working on it now. I think it's the best time to do it is now. You don't want to wait till the last minute to get it done. I think it's kind of the better way to do it. Okay, so let's. I'm just going to copy Lab 5, which is what I called it, to Lab 5B. It's going to take a moment for me to do that. Okay, and I'll bring it up. In the meantime, any questions that you have around the singleton design pattern? So we need 2 copies, one for now, one after. No, you can use the one that I'm going to give you now for the one after the break. I'm just going to. I want you to practice with the one I'm giving you now, Michael. The one after the break will be. This is part of lab number 5. I'll probably post an update, but it'd be nice for you to work through it yourself. as opposed for you just to download the code after the break. One thing that I've included in this project is the standard assets, because we're going to need some of them to make our job a little easier when we do platforming after the break. Why? Because I've also included things like, and I'll show you in a second, a bunch of stuff in the project. All right, let me just let me turn off Teams because I don't want to be bothered right now. And I'm also going to turn off Outlook. Okay, so let's bring that up. So what I want to do is I'm going to open up my project now, and it's called Lab 5B. You guys are 5B, the other class is 5A. I'm just going to bring that up. Oh, darn it, it's not what I wanted. It's not what I wanted. Let's try that again. Sorry about that. 5B, not 5A. The reason why it's picking it up as 5A is because it's the same code. So let me do it the other way around. By the way, you should know how to launch your project just by going through here. Some people have asked, they said, how can I just double click and launch my project like I do with Visual Studio? And the way to do that is go into your project, go into assets, go into into scenes, and double click on your scene. If you double click on the scene, it'll bring up that project. Okay, and it'll bring up the project with the the version that you're using, the Unity version that you're using. Okay, so it's going to take a moment. One thing that you'll notice is that you're going to have to rebuild stuff when you bring it up. So this is 5B. One thing I also want to change just while we're started is I'm going to go into File, Build Settings, and Player Settings. I'm going to change the lab so it says 5B, not 4B. That's an important change. So when we build it across the simulator, it'll be the right name. Okay. And the other thing is, please change to Android. So change from PC, Mac, and Linux. Do this also for as soon as you start your exam, start it off, if it starts here, start it off in Android. Like just do a switch platform down here. That'll take some time. All right, so where am I and what does this project do right now? Well, right now it does the old project. So if I press play, then it's just going to do these random bullets, right? It's what kind of we left off last time. Random bullets, you know, you get it still does collisions with the ships, that's why they go away, and all that kind of stuff. It's pretty cool. All right, but what we want to do now is I have in the Bullet Manager these two scripts, Bullet Factory and Bullet Manager. I want to convert my factory first into a singleton, so I don't have to include it here in my Bullet Manager at all. Because now my Bullet Manager does two things. It does the Bullet Manager stuff plus the creational stuff. And I don't want Bullet Manager to handle both those things. In fact, we should be able just to call the factory without connecting to it in any way. Because look, the factory's not doing us any good here, right? Literally all we're doing is connecting to prefabs. And there's another way to do that. All right, so one thing to do is to remove this component. So we'll remove the component from here. And we'll just get rid of the reference that's inside of our Bullet Factory. In the Bullet Manager. So that's the first part. The next part is modifying the script. So if I go to the scripts, and if I go to Bullet Factory, let's make Bullet Factory into a singleton. Okay, now this is something that is on the Unity side using C#, not C++. First things first, if we left it at mono behavior would prevent us from making a proper singleton. Why? It instantly creates an instance of the Bullet Factory when it's in the hierarchy. as soon as I have it as mono behavior. Notice that we never have access to the constructor function, typically. We don't want this, so we want to take away a reference to the mono behavior class altogether. So where it says mono behavior, just wipe this out. That's number one. Causes a problem with our instantiate methods because instantiate needs mono behavior. So we're just going to put mono behavior as a qualifier in front of it. So mono behavior dot. Okay. This is trying to get access to its transform. It was connected to the manager, right, which is the bullet manager, and now it's not going to be connected to the bullet manager, so transform means nothing to it. Okay, so what I want now is a reference to the bullet manager, but we know we're going to get rid of the bullet manager. Bullet manager, it's going to go away, right? We're actually going to have something called a game controller, which is going to access the bullet manager, and through the bullet manager is going to go to the factory. So let's make that game controller now. So I'm going to make a brand new empty. We're going to call it game controller. We're going to tag it as a game controller. It's always good to do that. And I'm going to add a new script called game controller. That right now is not going to do much. I'm just going to connect my game controller script onto my game controller itself. It says I can't connect any scripts right now because I have an error in my transform. That's okay. I'll do this later. So it's asking me to fix this problem before I connect any scripts because it's trying to compile, right? So one thing to note is I don't have my own transform, but I want to have a reference to my game controller. So for now, let's just comment this out so we can avoid the error. We'll come back to this. So this takes away this error here, and then I can drag and drop my game controller to my game controller empty. My game controller doesn't do anything right now. It's just going to sit here as a place where we can store our bullets. Okay? Eventually it's going to do other things, but for now that's all it's going to do. Bullet manager is still a place where we're going to do everything for now. Okay? All right, let's go back to coding. So we want to make this into a singleton. Let's think about step one. So step one, like we said, let's make a private static instance, right? So that looks like this, private static, and we're going to make the instance of bullet factory. We'll call it instance. Okay, so that's the private static instance, and we'll set it to null. We'll initialize it. You'd have to do this in C as well. Step two, like I said, is make the constructor private. Step two, make constructor private. So private constructor bullet factory. Okay, constructor is now private. Excellent. Step three, make a creational method. We're going to call it instance, public static, and it's going to be called, it's going to return a bullet factory instance. We're going to call it instance. Okay, and make a public static creational method for access. And the way it's going to look is exactly what we've seen before, the classic method, which is if m_instance is equal to null, then we're going to make a new object. We're going to say that m_instance is equal to a new bullet factory. Now in C#, this is thread safe because of the way C# deals with things a lot more. And why am I getting an error? It says cannot implicitly convert bullet factory to bullet pool. Oops, what did I do wrong? To bull. M instance is equal to double equals. There we go. Okay, so if it's equal to null, then we're going to return it. So this is our method to get to have everything inbound. One thing we also need to do is now our references to our prefabs have to be reformed. So these are our prefab references. And this is a Unity thing, right? So this is something we have to take care of, right? Because before we just drag and drop our references to the prefabs in the prefabs folder. Now we can't do this anymore. What we're going to do instead is we're going to have our bullet factory call a method named start. And again, you can call it start, or you can call it init, whatever you like. It's your name that you make, right? So I'm going to declare these, instead of making them private objects, or make them, sorry, instead of making them public, we'll make them private. So we'll do that here. And we'll just move them up. So I like to put these next to any kind of private declarations of, variables. Any private variables, I like to kind of put them together, right? All right, so bullet factory is going to call a public method called, or a private method called start. We can make it so that instead of start, we can call it initialize. All right. I think it's a better name for what we're doing because it's our own class. So it's private, returns void, initialize. And what initialize is going to do is it's going to call this, it's going to initialize these objects up here. So we're going to say that regular bullet is equal to, and this is what we can do if you want to use our, we want to load a prefab. We're going to do it to the resources folder. We're going to say resources.load, and we're going to load the type of bullet, which is in the prefabs folder, and we're going to call the first one bullet, and we're going to cast it as game object. You need to do this because otherwise you won't have access to the, to the prefabs. We have to move it right now. We have to move our prefabs folder into the resources folder. We don't have a resources folder, which means we have to create one. So create a resources folder. And this would be, again, if you look at steps 1, 2, 3, I think this might be step 4 for Unity. Right? And this might even be step 5. So move it in there. We have those kind of things happening, right? And maybe even, because this, we're making it a constructor private, we're creating an initialize method. Maybe we'll call it initialize in the right way with a capital I here. That's what it's looking for. And we're going to do that for the other ones. So instead of regular bullet, we're also going to have fat bullet, and we're also going to have pulsing bullet. So there's fat bullet and pulsing bullet, and make sure they're spelled properly. So fat bullet and pulsing bullet. Okay, so fat bullet, pulsing bullet. So that makes our references there, which is what we need. If that makes sense. Let's make the move before we forget. So I'm going to go back into Unity, and I'm going to make a new folder on the in the assets folder called resources. And I'm going to take my prefabs and move it into the resources folder. Right. So now I have resources, prefabs, and notice that I have bullet, fat bullet, and pulsing bullet in there. Okay. So that I need to do. To solve this problem, I need a reference to the game controller, which is where I'm going to put this. So I'm going to say, let's make a new reference object, which is going to be private. So game controller reference, private, game controller. And in here, in the initialize, we'll say that game controller is equal to game object find object of type and game controller. That's one way of getting it. And now we have a reference to the game controller that we want to use to put in our transform other ways you could do that too. But here what you can do is you can say game controller dot game object dot transform. And that's going to basically take each of the bullets and put it inside the game controller empty as a parent. And this takes care of everything we need from a factory perspective. Are you with me? For the people that are watching. If you're not, it's okay. I'm recording it. But the great thing is this creates the singleton that you have. Thanks, Kat. Someone's with me. Okay. The stuff for you, Russ, is this part. The resources load part, which you probably know how to do already. So this is going to solve problems. You may have to do resources load in the future. And if you don't, what ends up happening is sometimes you get stuck dragging and dropping. Dragging and dropping is not always the best thing because you can't guarantee that those connections are going to be made if you kind of pass your project on as a package to somebody else. Okay. So this is number one. So now that we have the factory and it looks like it's working, we still have to correct the references to the factory. So going back to our Unity project, notice we have these errors and it says script initialization and blah, blah, blah. And there's a bunch of these errors that come up. Well, the reason why is because something is trying to use the factory in the wrong way. And of course, it's coming from the bullet manager. The bullet manager, which we're going to convert as well, has made a reference to the factory. But remember, we can't do this because of the singleton. So we're going to get rid of this reference. And instead of accessing the factory like this, we need to access through the instance. So bullet factory dot instance dot create bullet. Okay, that takes care of that error, and that is the reason why it was complaining. So I'm going to say, hey, bullet factory, go through your instance method and create a bullet for me and return one here. That's what it's supposed to do. Okay. The rest, it's going to be the exact same. So let's see if this works. We should have everything working just like we did before, just by doing this. And we should see these errors go away. And if I press play, then it should just work. Yay, we're good to go. Now we're using the factory, but we're not coupling it all to the bullet manager. It's completely decoupled. The factory and the bullet manager are completely separate. Okay, so pretty cool. Now what we're going to do is we're going to continue and change this so that the bullet manager does the exact same thing, right? So I don't need a bullet manager anymore at all. I'm actually going to delete the bullet manager from my scripts completely. So this whole object is going to go away. So delete. However, I know the player accesses the bullet manager and so does each of the bullets themselves. They access the bullet manager. They're tightly coupled, and I don't want that to happen. So let's go to that bullet manager script and turn it into a singleton. So here's our bullet manager. Again, step one, let's get rid of mono behavior. We don't need that anymore because it's not connected to any kind of game object anymore, right? So step one, we need to create a private static instance. So private static bullet manager m underscore instance is equal to null. Step two, make our default constructor private. So private bullet manager. Okay. Step three. we're going to make our creational method, right? Make a public static creational method for class access. And we're going to call that public static, and it's going to be called, it's going to return bullet manager. It's going to be called instance. And we're going to say that if m underscore instance is equal to null, then m underscore instance is equal to a new bullet manager, and we're going to return bullet manager. M underscore instance. There we go. So that's our entry point. So far, so good. Same. This is where, again, making a generic template, if you will, generic in C# for to take care of our singleton might be best. Max bullets and our game object queue is okay. All that can stay the same, right? No problem. Start shouldn't be called start anymore because we're not Unity. Mono behavior, we're going to call this init, and it's going to be public. So a public init, and we're going to pass in, because we don't have max bullets anymore, I want to pass in max bullets. Pass it in. So I'm going to say that it's going to be an int max bullets, right? I'm still going to keep max bullets as a public object, but we're going to make it a property. And the way to convert it to a property is you can use the prop shortcut, prop. If I just type in prop and just press tab, it's going to create a type that I want. So this would be an integer type. We're going to call it max bullets. And we're going to get this get set, which makes it a property instead of an instance variable. Later on, if we need to, we can expand the getter and setter to add additional functionality. And so in here, we're going to say that max bullets is equal to max bullets. And then we're going to use build bullet pool to create the bullet pool through the bullet factory. Okay, so that's what this does. So that is our bullet manager. The rest, my friends, stays the same. Nothing changes. Everything else is the same for the bullet pool. However, all the access to the bullet pool has to change, because so far we've been using the bullet pool to create bullets in our plane, our ship class, our player class, as well as the bullets themselves. They have to manage. So we have to change those two classes. Remember, we first do the change in class, and then we have to adjust everything outside of that. Luckily, we don't have anything else to do inside of our class in terms of initialization, but I would say definitely that our default constructor should remain empty. Why? Because we need some kind of an amount of bullets that we're going to create. Okay, so that's kind of something we're gonna use. And this init method would probably be like step 3. So again, step 3, initialize class variables and start the bullet pool. And remember, bullet pool is in effect bullet pool in effect is the object pooling. Okay, sorry, Kat. So did you have assignment 1 part 2? Can I finish this part and then I'll take questions around assignment 1 part 2? Okay. All right, so that is, we already have a 3. This will be 4. Thank you, Mike. I just want to make sure that there's like different steps here so you guys can go through it later on and then see what this looks like. All right, so let's fix this other part. So I'm going to go back to Unity here, and we have some errors. As you can see, they come up. And let's go into the player controller. The player controller is where we fire bullets. So in my player controller, we're going to have some issues. One, we're going to try and access the bullet manager in the wrong way. So let's get rid of this. There is no bullet manager instance this way. Remember? Now that the bullet manager is a singleton, we need to call the full bullet manager class and then instance. So we need to do that right here. Okay? Same thing here. So let's copy paste there. Wonderful. Looks nice. And that's it for the player class. There's nothing here, nowhere else where it accesses the bullet manager, just here when we fire bullets. The other place it's being used is in the bullet itself. The bullet returns itself back into the bullet pool, in the object pool, when it leaves the screen or if it hits an object. So let's go back into the bullet controller itself. Going back to here, I want the bullet controller. And in the bullet controller, it's trying to get a reference to bullet manager, and of course they cannot. So let's get rid of this. And let's get rid of this. And because my bullet controller now doesn't need a start, let's get rid of that. Because that's pretty heavy in terms of running every frame. Okay, in where it says bullet manager return bullet, we're going to just do the same thing we did before. Bullet manager dot instance dot return bullet. I'm going to grab all this and replace that over here too. So whether we leave the screen as an example over here or hit an object, we're going to return the bullet back into the pool. And that should be it. We shouldn't have any more errors. Let's go back to Unity and let it rebuild. No more errors. This is nice. But we haven't really called the bullet manager at all. And I'm going to do that in my game controller. So game controller, double click. It's going to bring this up. And for the first time, I'm just going to kind of extract that public integer called max bullets. And inside of my start method, I'm going to say something like, hey, bullet manager, I want to look at the instance and I want to init with my maximum bullets. It's clean. It's a one-liner to make to enable bullets in the game. That's what it does. If I didn't put this in, it's not going to break anything. Just the ship won't be able to fire any bullets because they don't exist. Okay. Let's see if this works. So back to Unity. We have to put a number in here in terms of number of bullets. Let's make it 50. And one thing we can also pass in later on if we wanted to make changes is like the type of bullets that I want my to be stored inside the bullet pool. And we can talk about a bunch of other options as well. All right, this should be good enough. If we did everything correctly, I should be able to press play and we should just have bullet firing again. Just like before. Except for this time, we're in a different state. We've decoupled our bullet factory from our bullet manager, our object pool. Those two patterns are separate now, right? And the only place we access them is inside of our game controller. Our game controller calls bullet manager, which stores 50 bullets in the pool, and then our player reaches out to the pool and grabs the bullets it needs to shoot at the enemy. Enemy theoretically could also grab some bullets from the same pool and shoot them back at the player. Or, if we're smart, and this is the next step, what we could do is we could differentiate the types of bullets that the bullet manager has. So for example, right now we only have one bullet pool. We can have more than one. We can create any types of bullets we want. Right now, a random bullet's being created as an example. We can take that enumeration and specify that we want that type of bullet to be created. And we can pass that right through the initializer. So a way that would work would be make some changes to our code. So we can say that, okay, I want to initialize the type of bullet. So we can say bullet type, which is type. Okay, so we want the type to be initialized, right? So as it's being created, our pool, as it's being built, we can specify the type of bullet that we want to put into the pool, right? And we don't want this. We just want to specify the type, which would become from here, right? So we'll say the number and type of bullet. So bullet type, we pass that type into here, which passes it into here, which creates the type we want. And instead of create bullet being hard-coded as random, we can pass the type into the create bullet method, which is part of our bullet factory, to create whatever type we want. And then inside of our game controller, so let's go back to our game controller, we can have a bullet type. So we can say public bullet type, and we'll take that bullet type, whatever the user wants, and we can pass that into the initializer. And if we want to make it simple, then we can make the initializer itself have defaults, which I'll do right now. So go back to initializer, go to definition, and the initializer itself will make it so that the bullet type is equal to a regular bullet, if you don't specify, instead of random, and the maximum number of bullets will be 50. So if I don't specify, it'll just choose something for me, okay, in the initializer. So going back to my game controller, this is okay. We just have to fix our bullet type. And bullet type, because it is an enumeration in the inspector, it's going to come up as a pull down, where I can specify if it's a regular bullet, a fat bullet, a pulsing bullet, or random bullet. One more nice change we want to make is we want to definitely put a header on these two things, which is something to do with bullets. So we can say that, hey, we want a header that have to do with, you know, something to do with, you know, bullet related. And we might be able to change that later on. So now you can see it bullet related comes up there, and we see that maximum bullets, 50 and regular, and if I press play, we should see only regular bullets now, because those are the only ones being stored in the pool. Or if it was an enemy that was firing back at me, I could say, well, they're using fat bullets. So the enemy would be using fat bullets instead of the regular bullets. Now there's a lot more really cool functionality, and it's in one little script, right? So it's way better than what it was before. All right, that's the end of my demo. Questions about this, about the singleton pattern and how we can use it? And here's another better question for you guys. Would you use it? That's the other one. I've given you some advantages and disadvantages. What are your thoughts? Russell says yes. Anyone else? What about Michael? Michael, what are your thoughts around it? Michael says yes. He says yes. Anyone say no? Anyone say that they probably wouldn't use a singleton pattern because they don't like it, it's not thread safe, or whatever? Yeah, most people will tell you. I mean, I'll for the most part, we use the singleton pattern a lot in game dev. Tons. Maybe too much, right? But the great thing is it creates structures for us that are reusable, structures for us that are easily accessible, which is what we want. The way we did it is thread safe, but some people might complain that it's not good, right? As an example. The other thing that some references, things that you want to explore after this on your own, is how do I make a generic or template in C# so we can avoid some of the duplication of code that we use between our bullet manager, like this stuff, and our bullet factory, which is the exact same. Is there a way we can templatize this and we can inherit from our a templated version of our singleton class that we can use, and will it work the same way? All right, so that is all I wanted to talk about here. I'm going to put this up on GitHub when we come back, because this is going to be the first part of our Lab 5 that we're going to use because I'm going to introduce touch controls. One thing I've included here, we can't use this bullet manager for enemies. If you want the enemies to shoot bullets at us, they would share the same pool. Correct. What you could do is, like, this is some stuff that I was going to close off with, but thank you, Michael. What you can do is in your bullet manager, right? Remember that right now we only use one cube, right? There's a couple ways to do this. You could, it's a resource manager, right? That's what it is. So you could have the bullet manage all bullets. Bullet manager manages every kind of bullet. Enemy bullets, fat bullets, random bullets, all kinds of stuff from all kinds of places. Not just the enemies, but maybe even the environment. So right now, the methods that we have are named such that you can only get one type of bullet. For example, get bullet only returns the default bullet that's in the pool. But you could specify, you know, the type of bullet you want. So get bullet, we could make a, there's two ways. We can make it an overloaded method that has a different signature, as an example. And or we can just add the type of bullet that we want. I want a bullet that is a fat bullet or a regular bullet or whatever, right? And instead of going into the pool and dequeuing from my bullet pool, I could have different pools of different kinds of bullets that I want to get. Okay, so that's one thing we could do. So an example of that would be I can have, you know, I can create all the stuff I want for my enemies, my environment, maybe environmental bullets, let's say bullets or fragments that come from different places. Like, for example, some games used to have random missiles that would come from nowhere. It's not really coming from an enemy, it's coming from the environment, some kind of random missile, right, as an example. And so you would have that in a separate pool. The manager can hold multiple pools, different kinds of bullets, as an example, if you want the enemy to fire back. And also, if you want to specify, we could also configure the bullets themselves. The bullet controller right now only fires straight up, right? So one thing that happens is the bullet moves, but the bullet moves in a straight line upwards. One thing you're going to have to do for your test is you're going to have to change this so it doesn't move upwards, it moves somewhere, another direction, right? So that's something you have to change, right? But maybe what you can do is in the move function, maybe you can, there might be an initializer or some kind of accessor that you create for the bullet controller so that you can modify the direction of the bullet as well as the type. Like, there's lots of stuff you can do here to make it more flexible. Okay, so that really is all I wanted to say. Kat, you had a question I'm going to answer after I stop recording. But that's it for my example of the Singleton for our course. Okay, I'll see you again. Just for people who are watching the stream. Like I said, next week there is no class. It'll be in 2 weeks from now. I'll see you guys in the same time, and in 2 weeks we're going to be starting up a whole new thing with using physics in 2D games for our mobile game design. Okay, we'll talk about that when we come back.